Hello friends, our topic of today is what's inside a cell phone charger. So let's look about it. This is a normal cell phone charger, and this is the inside part of a cell phone charger. First, I'll introduce you with all these components of a cell phone charger. What are all these electronic components? So we'll start from here. This is the input side of this cell phone charger. Here you can see this is a resistance. You can identify resistance by these color code lines, and you can also find out the value of this resistance by this color code lines. After that, you see these four cylindrical shaped things. These are diodes. So you can find this is the positive of the diode and this is the negative part. You can identify by this white line that this is the negative part of this diode. This is the capacitor. This is the electrolytic type of capacitor. This is the negative polarity of the capacitor, and the value of this capacitor is 4.7 microfarad. You can read out here. This blue thing is also a capacitor, but it is a mica type, non-electrolytic type of capacitor. Here, if I tell you about this thing, this is a MOSFET. This whole the thing with a hole, this is a MOSFET. We'll see what are the uses of all these things. This is a normal transformer. Okay, then this is a LED light. This is a chip, IC chip. Okay, and this is also a capacitor, and this is a diode. Okay, and now we'll see what are the working, how does this cell phone charger works. Now we'll see these are the main components we have seen about: diode, capacitor, MOSFET, and transformer. Now, if I'll tell you about the working of this system, is first we'll be getting that 220 volt input AC from our input port from the supply. After that, this input supply will be rectified by a bridge rectifier. Here, if I'll tell you in the circuit where is the bridge rectifier, these four diodes in this arrangement, these are connected in this arrangement, and these work like a bridge rectifier. After that, the DC supply is not perfectly DC, so we smoothen that DC by reducing the AC component in that part, and that is done by a capacitor. You can see here this capacitor. After that, this DC supply, this kind of a perfect DC supply, is converted in a high frequency AC signal, because if you have to feed this transformer, you have to give it AC. Transformer do not work on DC, so this high frequency signal is converted by this MOSFET, and after that, this transformer step down this AC signal, that very high frequency AC signal, into some lower value of that voltage, some 5 to 6 volt, and that AC signal, that a lower value AC signal is converted into DC again by this diode and capacitor. This here it is a diode, and this is the capacitor. If I show you, you can see here a diode and a capacitor. Now the question arises, why high frequency? Why we are using high frequency? You can just convert this AC into DC and just step down directly. Why you are using this MOSFET to high frequency? So the answer to this question is switched mode power supply. Now, if you will not be using high frequency, the normal system will be working on 50 hertz system, and on 50 hertz the size of this capacitor and this capacitor will be very huge. To make up this conversion. Also, the size of this transformer, which is a kind of 220 to 5 to 6 volt, and maybe the ratings may vary a little bit. The size of this transformer will be very huge. So to reduce the size of this transformer and to reduce the size of this capacitor, we will increase the frequency, because on high frequency the capacitance is inversely proportional to frequency. So if we increase the frequency, the capacitance will reduce, and if capacitance will reduce, the size of these capacitors will reduce. Also, at high frequency the size of transformer also reduces. So we use high frequency. Now, if you want to change the frequency of AC signal into some other frequency, you cannot do it directly. You have to convert it into DC. So what we have done, we have converted this 50 hertz AC signal into DC signal. Now suppose this is the DC signal, and you have switched on off very frequently this DC signal, and that has become like a AC signal. If you see, the MOSFET does this thing, it switches on off very frequently, and converted this DC signal into kind of a AC signal, and that signal is fed to this transformer. this transformer steps down this AC signal, and we get a lower value, lower voltage value of this signal into this output. And on that output you have, as you need a 5 to 6 volt DC for your cell phone, for charging of your cell phone, this AC signal is again converted into DC signal by this diode and this capacitor. Again this capacitor is used for smoothing the voltage. Now if I show you the circuitry, the normal circuitry of this switched mode power supply, see here it is the resistance is normally used for this, you say the limiting current limiting. Okay, now that after that here you can see that bridge rectifier, then this capacitor, then this transformer, and this is MOSFET. And the output of this, the secondary of this transformer, you can see this diode and this capacitor, and this is the output of your input of your cell phone and or output of this charger. So this is it. Thank you. If you like it, please subscribe, share, and give a thumbs up. Thank you. With cameraman Mohit Gupta, Prashant Sharma. Thank you.